from there. So we have studied standard form, index form. Now I proceed from there. Here I write some terms in index form, polynomials in index form. X to the power 5 plus 4x square plus 4x cube, 4x square, 0x minus 7. Okay. Another example. First example. Second example. Y to the power 5. 3y to the power 5 plus 0y to the power 4 minus 2y cube plus 0y square plus 0y minus 2. Okay. So here I have written two examples in index form. In index form we have to write missing term. In standard form there is no need to write missing term. Index form you have to write missing term. So here I have written in index form. Now we want to study coefficient form. Coefficient form. Coefficient form of polynomial. So for coefficient form, you have to write polynomial in index form first. In index form. And then in bracket. Now in bracket, you have to write only coefficient by giving commas. For the coefficient of x cube, that is 1. So 1. Then comma. Here 4. There is no need to write plus sign. So 4. Then coefficient 0. And then that is minus 0. That is the coefficient form of this polynomial. That is index form, that is coefficient form. You have to write only coefficient. Now here, second example. This one, again, coefficient form. First of all, make bracket. What is the coefficient of y to the power 5? 3. So 3. Then give comma. Then next coefficient, 0. There is no need to write plus sign, but if there is minus sign, you have to write with proper sign. Now, coefficient of y cube, that is minus 2, so you get minus 2. Then, coefficient of y square, 0, so 0. Then, coefficient of y, that is 0. And then last one, constant term, that is minus 2. So, in this way, you have write the polynomial in coefficient form also. Coefficient form also. That is index form, coefficient form. Now, we converted this into this. We converted index form into coefficient form. Now, let's study how we can convert this coefficient form into index form. Now, index to coefficient. Now, we want to study coefficient to index. So, let's consider some example how we can convert coefficient form into index form. Here coefficient form. Here first example 3 minus 2 5. Second example minus 3 minus 2 0 5 minus 1 9. Okay. So here I have written these two polynomials in coefficient form. Now I want to convert them into index form. How to convert coefficient form into index form? So here whatever. Count number of terms. 1, 2, 3. How many terms? 3 terms. So when your number of terms, now we want to consider variable and their power for index form. So whatever number of terms, consider power of variable less than number of terms. Here number of terms. That is 3. So for power, this minus 1. Every time subtract 1. So how much? 2. So here, how we can write down these 3 and then what your variable x. So here, this power 3x square. Then, sorry, then minus sign, minus 2, then write down this variable in descending order. In this way, it gets converted into index form. Now, here second example. Consider number of terms 1, 2, 3, 4, 5. So here number of terms, that is 5. So for power of variable, that is 5 minus 4, that is 4. So you have to start with power 4. We have to start with power 4. Here we can say starting power of variable. Now you can use any variable. If not given, you can use any variable. So here write down this coefficient minus 3 and then starting power at 4. So 3y to the power 4. Then next coefficient minus 2 and now add on these powers in descending order. Y cube, then plus 0y square plus 5uy, and last term, that is a constant term. That is a constant in this way. Starting power, count number of terms, subtract 1, that will get starting power of the variable, and then write down this coefficient and then write down these powers in descending order with that coefficient. In this way, you can write coefficient form into index form and index form into coefficient form. Okay? Now, some homework to you. Now, some homework. So, remaining question. Just check me, degree, linear quadratic, okay, in standard form, okay, coefficient form, okay. Up to question 8. Practice set 1.1 from 1 to 8 on practice or homework. Practice set 1.1 from question number 1 to 8, practice or homework. Now, I will consider question number 9. Here, question number 9. Now here, binomial. Monomial. Quadratic polynomial. 7 x cube plus x cube plus x square plus x plus 5 2x square plus 5x plus 10 2x square plus 5x plus 10 then x cube plus 9 3x square plus 5x. Okay, that is the question. Now, in this, you have got only binomials, the polynomials which contains two terms. Which contains two terms? X plus 7. Consider only terms here. Again, two terms, that is two terms. X cube plus 9. Again, it contains two terms, that is 3x square plus 5x. So in this, you have to write binomial, that is which contains two terms. That is two terms, that is two terms, that is two terms. Okay. Then here trinomials, which contains three terms. Three terms, there is only one. 2x square plus 5x plus 10. 2x square plus 5x plus 10. Okay. Only three terms. 1, 2, 3. Not less, not more. That is trinomial. Then monomial, which contains only one term. Check this. Only one term. Okay. So on the basis of terms, you have to write here. We have written now here. Quadratic on the basis of degree. Quadratic having degree 2. Take this degree 2. So you have to write here x square. Then again degree 2, that is 2x square plus 5x plus 10, that is degree 2. Again check this last one, degree 2. 3x square plus 5x. So here you have to write all the polynomials which have degree 2. Okay. Now cubic polynomial having degree 3. Check this degree 3. Check this degree 3. So here x cube plus x square plus x plus 5. That is first one. The second one x cube plus 9. Degree 3. So here cubic. Linear having degree 1. Linear is degree 1. There is only 1. That is x plus 7. X plus 7. In this way, we have to write these polynomials on the basis of their terms, on the basis of their degree. So here, in this way, we have completed 1.1. And in that, what we have studied here? So here, what